Good evening, students. Can you all hear me? Everybody? Okay. Thank you so much for your response. Also, I can see, okay, on which topic we have to present the project. Topic or given by mentor or choose by students randomly. See, Ramavat Sidhu, to answer this question, not just for him, but for everyone who has this question, it seems that you did not attend the AMA session. Because every week, Friday, we conduct this AMA session in which we have clearly mentioned that the choice of topic is yours. Okay, you can do any project, but the project template will be given by us. You need to put your prepared content in there and you need to submit it on our LMS. Okay, but the choice of topic is yours. And in that, whatever topic that you are choosing, please include artificial intelligence and machine learning. So already the trainers, they've been explaining this in all our sessions, including this AMA sessions. So far, we have conducted 2 AMA sessions. Please do not miss it. Otherwise, you will miss a lot of other important pointers. Right? So please do work on your projects. The choice of title is yours. Okay, but please infuse artificial intelligence and machine learning into that. And Aravind, you're asking about Microsoft voucher. So we did not receive any updates on that yet, right? So once we receive the update, we will keep you posted in the group. Okay, else you will be directly contacted by Microsoft as it is a token-based system. Token as in like a lottery-based system. So if you are shortlisted, they will reach out to you to your submitted email ID. Okay. And otherwise, ma'am, when will the templates will be given to us? See, you will get the updates in the Telegram group itself, Sheikh. Okay, we will be sharing the template in the Telegram group itself. And in today's session, the trainers will share you more updates about that. Okay. Okay, Noor is asking, ma'am, in advanced section of LMS in Microsoft Azure AI Fundamentals, Computer Vision Module 2 and 3 are same. Okay, thank you for bringing this to our notice. I'll ask the tech team to check this, okay? How many days are alive to start project? See, you can start your project by onwards because the trainers, they've been giving you the inputs for your projects. Okay, so you can start working on your project. Once you receive the template in the Telegram group, you can start pasting the content into the PPT that we are sharing and convert that into PDF. Then it is good to be submitted in the LMS. Okay, the trainers will take you through the template and everything before they share it in the group. Do not miss any sessions. Otherwise, you will again have to start from the first. So please ensure that you are attending all the sessions. Okay. Right. Last date for submission. For if you are asking about the project submission, then 15th of July is your last date. We have 40 more days for that. Right, 15th of July is the last date to submit your project. Is to submit your project, and 12th of July is the last date to complete your courses. Okay, 12th of July is for the course completion and 15th of July is for the project submission. Anything else that I can answer you? Okay. Yes, Neil, I just told you, choice of topic is yours. Yes, for June batch only, I just mentioned like 12th of July is the last date for course completion, 15th of July is for project submission. And this is for the June batch only. For other batches, the dates are already passed and they have got the certificate also. For May batch students, if anybody is there, please note that we will keep you posted in your group. Maybe by this week, you will be receiving your certificate. May batch students, not for June batch. Don't get confused. So June batch students, your deadline is given as 15th of July, right? And maybe after that, a deadline will take 1 or 2 weeks of time to validate your projects. And students who have cleared this eligibility criteria, you will receive your certificates. So for that validation and filtration process, we would need 1 or 2 weeks of time, then you will get it. Okay. Ma'am, what's the project to do? Please refer to the other session recordings, Madhav, because we've been answering this multiple times. You need to be really very attentive in the sessions, and you should not miss out any points. And you should not be late to the class as well. Because I can see there is a sudden increase in numbers while I share the attendance link here in the chat. Otherwise, I don't see much of crowd here. So please ensure that you're attending the sessions from the first to make this internship a fruitful one. Template will be provided to you in the group. So today the trainers will give you more updates on that. Sure, Noor. They will be giving you the revision of classes. Yes, you have all the recordings with you in the Telegram group. Please do refer them once. Okay. Attendance link has not been shared. No, we have shared it in the Telegram group. If you check the group, you will get it. Attendance link we've been giving in the group. Till the last session, AMA session, if you scroll up in the group, if you check the pinned messages, you will be able to see the attendance and recordings for all the sessions. For AMA session, we won't give the recording because we would want the students to attend it live. But you have the attendance link pasted in the group for all the sessions. You need to check. Am I audible to all of you? Pal, I think it should be your network issue. Please try to rejoin the session. So all clear with all of you, right? And for the attendance links, please check the Telegram group's pinned messages. It is all there. So see, some students are asking for the attendance link for the session, for the non-session dates. For example, I have come across this question on LMS. Ma'am, we did not receive the link for 30th of June. That is yesterday, right? We did not have any session on 30th. You need to have the schedule sheet ready with you. Every week, Tuesday and Thursday, you are having your mentor-led sessions. That is your technical sessions. And Friday, we have AMA. Only 3 days a week, we are having sessions. Otherwise, Monday or Wednesday, Saturday, Sunday, we don't have any sessions. So there is no attendance. Please ensure that you're checking the schedule before you are asking for the attendance link. Okay. So for 17th, okay, one student is asking that for 17th, just give me 1 minute. For 17th, also check the pinned messages. 17th also, check the pinned messages in the Telegram group. You will get it. It is there. Just check your pinned messages. Okay, I think I can hand over the session to the technical trainer. Thank you, everyone. Over to you, sir. Thank you.
Okay, thank you, ma'am. So one question I can see in the group, sorry, in the chat box, I have selected AI resume analyzer. Yeah, you can go for that project. So any project that is related to AI, you're implementing AI or machine learning, you can go for that project. All right, perfect. Iris flower classification, it is very, very basic level project, Vanuska. Okay, guys. Before moving ahead, let me check. Is my voice clear to everyone? Loud and clear. Is my skin visible? All right, perfect. Yes, you can build a assistant chatbot. Yeah. Okay, guys. Let me clear one thing for you. Few questions are very common here in the chat box. Like, can I upload my project on GitHub and all? Yes, you can upload your project on GitHub, and that GitHub link you can mention in the project PPT that you're going to create. All right. Okay. And yeah, so few students are asking like about very, basic level project. Don't go with basic level project, right? You are doing this internship and you will be, adding this thing in your resume. Interviewer will ask you what project you have worked on. Are you going to show those simple projects? No, right? So the project that you're going to mention in your resume represent yourself, right? Try to come up with good projects. Yes, sign language recognition will work. Yeah, nice project. Okay, I think we can proceed now. Guys, this type of question you can ask in AMA session. Okay, AMA session is for this only. Okay. I hope we can proceed now with our today's topic. All right. So last week we have worked on supervised learning. In supervised learning, we did one project on regression and we did one project on classification. Right. Now today we will be discussing about unsupervised learning. Right. So basic all the things I have already discussed with you, but we are going to discuss again what exactly unsupervised learning is, what is the difference between supervised and unsupervised. We are going to know the concept of clustering, what are the different types of clustering and application, and we will be having one hands-on today. Hands-on, that is going to be a project that is based on unsupervised learning, type of clustering project, and the project name is going to be movie recommendation system. All right. Now, what basically unsupervised means, right? So what we have done so far, we have trained the model on supervised data, right? Supervised data means what? Label data, where we were having a Y column. Based on X, we have to predict Y, right? But in unsupervised learning, we are going to have unlabeled data. Now, what you can see on the screen, we are just showing a diagram, flow over here. So we are just giving the fruits over here, right, to the model, the picture of the fruits. We are not saying like this fruit is apple, this fruit is orange. No, the model is going to understand what are the similarities between different data points, which data points are similar to each other, which data points are different. Based on that, it is going to separate it and is going to make a cluster of it out of it. Cluster, I hope you have heard about cluster. This word cluster of stars, what we used to call it, group of stars. So cluster is nothing but we try to group the data based on their similarity. Yes, grouping similar objects. Yes, exactly. So basically, the algorithms that we will be using, one of the very famous algorithm we are going to use today, that is going to be k-means. Basically, it is just going to be used to discover the hidden patterns or the data grouping without the need of human intervention. That is what we try to do in unsupervised learning. Moving ahead, let's try to understand what is basically difference over here. So what we have seen in supervised learning, we had classification and regression. In classification, we were trying to predict the target value based on the class, right? Based on the class, like it is yes or no, good or bad, like that. In regression, we were trying to predict some value, a continuous value. It could be a price of something, price of car, price of home, count of something, right? Now, one thing was common in supervised learning, that we were only talking about the data that was having Y column. Y column, I'm just, using the Y so that you can understand the label data. Wherever you're going to have Y column, that means you're having label data. If you have to something to predict based on X, you have to predict something. That is going to be supervised learning. In supervised learning, we had classification and regression, and we have done one project on both, right? So in unsupervised learning, what we are going to have, it's going to be basically totally data driven. Supervised learning was task driven. We were giving one task, like your task was to predict the level. But here in unlabeled data, we try to do a lot of things over here. So the first application is going to be clustering. Clustering is nothing but dividing the data or grouping the data based on the similarity. Now, you might have seen targeted marketing, right? Targeting marketing means what? If you talk about any platform like any e-commerce platform like Amazon, Flipkart, and all, so what they're trying to show you, the product that you're looking for, you will be getting notification for the similar type of products, right? The product that you want to buy, that you're like to buy. And talking more about it, like it is also is getting used to understand what type of things you like. Like the second thing is going to be association. Association means what? Identifying the sequences, right? So basically, we are trying to recommend something based on the customer's choice. On YouTube, what you watch. If you're going to open YouTube, you're going to watch 4 to 5 videos of same genre. Close the YouTube app, open it again, you're going to see say similar type of videos, right? If you're listening to Arijit Singh songs, you are going to get recommendation of the similar videos, or you can also get a recommendation of the videos or the songs that is similar like Arijit Singh song. Like you can get songs of Vishal Mishra or the singer who was like singing in the same genre. Or if you're watching Shinchan all the day, you will be getting Shinchan only, or any animated cartoon related to the same. So the next thing is going to be dimensionality reduction. So what we try to do, basically, dimensionality reduction is not any like we are not going to implement any machine learning technique over here. It is just a concept. Concept in this, what we try to do, we try to reduce the dimension of the data. Dimension of the data, what I mean to say by like putting the dimension of the data. So dimension of the data is going to be like, let's suppose you're having lot of redundancy in the data. You're having lot of features that is not required. So we try to compress data. Okay, one question is like, can you give more clarity between clustering and association? Right, okay. So clustering is going to be dividing the data based on the similarity. So one example we can take like targeted marketing. Targeting marketing means what? So if you talk about the ads, what type of ads you see? The ads you see, the product that you're looking for, right? So all the platform that are going that are earning through ads, what they promise to the companies, those who are spending the amount of money to show you the ads, they promise that I will be showing the ads to the targeted audience. Targeted audience means what? The customer who are more likely to buy that particular product. If I want to buy a laptop, I will be getting the no ads of laptop. From where it will come? It will come from our like our cookies. Whatever you do online, you are creating data. Whether you are browsing, surfing, scrolling and all, you are creating data, and that data is getting used by this platform to give you targeted ads. Talking about association, in association we try to understand the sequence means what? Like recommending some movies to you, right? So here we can club together clustering and association that we are going to see. Yes, perfect example, basket analysis. Let me explain this particular association thing clearly. All of you have like done this problem in school, this thing in the statistics chapter. So let's suppose there are three products. The products are bread, butter, and milk. Let's suppose customer one is buying bread, butter, not milk. Customer two is buying bread, not butter, but milk. Customer three is buying all of them. Customer four is buying only butter. Customer five is buying only bread. Customer six is buying only milk. Or like you can see, like you will be getting 9 different combinations over here. 9 different combinations like this. Now here, what we try to understand, okay, if a customer is going to buy bread, then what are the chances they can buy butter or they can buy milk. If they are buying milk, what are the chances they can buy butter or bread? That is market basket analysis. And I hope you have seen this problem in school. You have solved this in the statistics chapter. Now, through this, what we try to do, we try to gain some confidence like on one product. If a person is buying this product, they can also buy this product. The same things comes to, in real life situation. In real life situation means what type of reels you are watching, right? Yes, support confidence. Yes, exactly, Ravindra. What type of reels you are watching, right? You will see the similar types of reels you are getting always, right? I can also categorize between boys and girls. Boys mostly will get reels based on, I'm talking about Instagram or YouTube Shorts. You will be getting mostly reels or YouTube Shorts based on, cricket, football most of the time. Girls are going to get, yes, comedy also. Girls are mostly going to get reels based on, yeah, they will be getting comedy also, but there will be like some uh, product centric reels, right? So you will be getting some unboxing videos, you will be getting reels about, like showing some dresses and all, makeup products, right? Like this. Similarly, you will also see the different type of reels in your mother's and father's phone if they are using Instagram or YouTube Shorts, right? Your father will be getting more reels on, news shorts and all, or podcast and all. What I used to see in my father's phone, when you are going to open your mother's phone, you will be getting, shorts of Anupama and all, right? That is TV serials and some home decor products and all. So that is what we try to achieve with the help of association. I hope it is clear till now to everyone. Is it clear? Can I get some thumbs up in the chat box? All right. We'll be talking more about clustering. What is clustering? Okay. So we know it is an unsupervised machine learning technique. Why we are using clustering? So with the help of cluster, we try to group the data. We try to group the data. If a data point is, closely packed to each other, if they are related to each other, if they are, residing, uh, you know, with other data point, that means they are having some similarity. Let me, explain this with a real-time example from your class. How many students are there in your class? How many students are there in your class, in your college? 60? Okay, mostly 60 you will get. Yeah, 60, 50 like this. Okay, I'm getting the responses. So majority the response is 60. Now in this 60 students, you are going to get uh, 10 to 12 different groups of friends. 10 to 12 different groups of friends. Now, why there are different groups over here? So groups are nothing but, cluster of like-minded people. Like-minded people attract each other, they become friends, they start sitting together. Right? That is how like you have selected your friends, because your friends and you are like having same mindset, same goals, or similar vibes. Okay, I'm getting good words over here, vibes. Okay, matching the vibes, right? So from your group only, anyone can say, who are you? What type of person are you? Right? We usually, hear from our parent that try to create a good group of friends, right? Be in the good group of friends, because group of friends also represents you. So that is going to be cluster. Okay. Yeah, same political party. Yeah, exactly. This thing, I know this thing will come. Yeah. So basically, we try to club similar objects, similar data points together to form a group. That group we call it as cluster. Backbenchers group. Okay. Exactly. Moving ahead, what exactly we try to achieve with clustering? Okay. Like there will be few more questions like how many clusters we should create, based on what the cluster is going to be created. Let's try to understand. Okay, talking about clustering over here. Clustering. Now let's suppose, just a second, let me fix something. Yeah. Let's suppose we are having one graph. All right. On this graph, I am having some data points. Okay. Let's say we are having some red points over here. We are having some blue points over here. Now, each data point represents one row. Okay. Each point that you can see, it represents one row. Then we are having some yellow points. All right. Now what you can see here, I have given it color, but what if it is of all the same color? This is what we try to achieve with the help of clustering. Now, why we are doing like this? Let's suppose we are having, data set of customers. We are having data set of customers in which I am having customer gender and customer age. There is no column called Y. We are not having any column called Y. Now, based on the gender, what is male 18, female 20, male 35, female 36. Like we are having multiple rows over here, a number of rows. Now, based on the gender or age, we want to group the customers, right? Why we want to group the customers? Because like different set of customer, if I'm going to talk about this particular data, male of 18 year of age, they are going to have different choice as expected to male of 35 years of age. Same thing will go with female also. Female of 20 year of age is going to have different choices as compared to female of 36 year of age. Right? Now here we try to create clusters. We try to group this data into different clusters. Now why it's so? Why is it so? Why we want to group it into different clusters? Another question is, let's say we are having cluster A, cluster B, and cluster C. If two data points are closely packed or they are near to each other, that means these two data points, I'm talking about these two data points, that means they are having some similarity. Similarity means what? Let's suppose it is a male and male of 18 year of age, and I'm having one more male of 20 year of age. Now, there is not that much age difference. There are some similarity. So their choice can be same, right? Like, let's say these two are just, more into games. So I am going to recommend them gaming consoles, gaming laptop. And let's suppose these two data points are over here. These two data points are over here for, let's say, female of 20 years and let's say female of 19 years, right? Again, there is not that much age difference, so they can have similar choice also. They would be looking for, like similar type of products. Like if you talk about, females, so females are more likely to buy, mobile covers, each month. If you talk about boys, boys are not going to buy mobile covers. I'm talking about, based on the market data. If you talk about boys, boys will be using the same mobile cover for a whole year or for 3 years. But girls can change mobile cover, like if they are going to find something new. So they will be looking for new products on Amazon, on Flipkart. So similar type of products, I'm going to recommend them. Let's suppose I'm having these two data points. This is for, let's say, male of sorry, let's talk about female. Female of 40 year and female of 42 years of age. Right? Now, what you are going to see, if these two females are like sharing similar type of age, they could get similar type of products, right? They could buy similar type of products. They could buy some, kitchen utensils. They will be more likely to buy, let's say, home decor items and all. And one more thing here, I'll tell you. I'm talking about, let's say, female of 30 years of age, or let's say 32. Now, based on the market data, if you are a female, you are 30 years of age or 32 years of age, or let's say, I'm taking one age range, let's say 25 to 35 or 30 to 35. Okay, 30 to 35. So these females are going to be more likely to buy baby products, right? Baby products, right? Now, you know why they are likely to buy, because most of the females will be, mother in this age, right? Most of the mothers that you will see, like new moms, they are going to be of same age, this age, 30 to 35, right? Now, based on this, we can also recommend the similar type of products to them. Now, talking about baby products, do you think this group will going to buy this product? No, right? This group is also not going to buy this product. This group could buy, but these groups are going to be more likely to buy this type of products. This is what we try to understand from the data, right? Okay. One very good question, like asked by Divya over here. What if we manipulate data being 18 years? If I give my age 30 and look out some 18 years of girly stuff, do I fall under 30 years of categories? No. So here association will come. Concept of association. Right now we are talking about machine clustering based on the given data, right? Based on the given data. Now the data that you are going to feed, now here the concept of association will come. Association means what? Like the more thing that I'm looking for. I'm exploring dresses. I'm exploring about makeup products, or I'm exploring about glasses and all. So I will be getting recommendation of those products only, right? You can also see the same in the YouTube also. What type of videos you are watching? Yeah, the type of video you watch is going to be different from your friends, right? What type of videos they watch on YouTube? Let's suppose you are more into, classical singings and all. You like classical songs, but your friend only listen to pop songs or rock genre songs. So he or she is going to get the similar type of recommendations based on their similarity. Now, why we are creating this cluster? Now our cluster is going to be like, what if a new data point come in the picture? What if a new data point come in the picture? Based on the distance, again, here we are going to use one distance metric. I'm talking about that particular algorithm. We will be discussing about it, K-means. We will be using Euclidean distance. Euclidean distance, right? First, they would segregate my data accordingly. So the thing is that all the things will get, fed in the database automatically, right? As you are going to feed the data. If you are a new customer, you are new customer, guys, try to like recall the first time you opened your account on Amazon, the first time you opened your account on Flipkart, what type of products you got recommended. That means you are a new data point over there. Now here this platform are thinking what to recommend you, right? Again, I'm taking the same example. If you are a boy, most likely you got like gaming consoles, football, cricket bat, this type of things in recommendation. Most of you might have created your first time your ID on Amazon or Flipkart in 15 to 16 years of age. That time boys are more into games. They are more likely to buy cricket bat. They are more likely to buy football or any electronic device. If you talk about girls, girls are more into clothing, right? They like to do the window shopping. They try to explore what are the new collection came in Myntra, in Nika and all. So based on your behavior, yeah, chocolates also. Nice example given by Prince. Based on the behavior. Behavior means what? What we are trying to search, what we are trying to explore. Yes, cosmetic collection as well. So all these things will get recommended. This is what we try to do in clustering, right? Similarity, yes, exactly. Okay, answering to your question, Chris. Chris is asking, is clustering and association is both algorithm work simultaneously on the website like Flipkart? Yes, exactly. So association is going to work on the if you talk about association is simply it's going to work on the old customers, you can say. Clustering is going to work on the new customer. And it is not like that clustering will not work on old customer. It will also work on old customer. Clustering is going to be machine learning algorithm. Association is going to be a technique. Okay. Grouping the data and things. Exactly. I hope clustering is clear to you. You got the difference between clustering and main difference. I just talk about the main difference, Sonu, right? Clustering is going to be the machine learning algorithm that will help you to identify the new data point, which cluster they are going to fall into. Association is going to work like to recommend you what type of things you like to buy or like to watch, right? Okay. What are the different types of clustering methods? Okay, clustering is not only going to be type of like single methods. There are different methods available in Python or any like in scikit-learn library that you can use. So the first method is going to be nothing but centroid based, or you can also call it partition clustering. Centroid based clustering, we try to do, we try to create some centroid. Centroid means what? Let's suppose here I am taking, let me erase few of the things from here. Okay. Let's suppose I have selected this data point as the center. Here, this data point at the center, or this data point at the center. So based on the centroid, model is going to understand. So first of all, this centroid is going to be, selected by the model. We will try to understand when we are going to, go through K-means algorithm, how the things are getting selected. So in centroid based clustering, one centroid will be selected and the distance for the all data points in all the centroid is going to be calculated by the model, right? Based on the distance of the centroid, we try to understand what is going to be the new data point, where the new data point will fall. That is what centroid based clustering is. So K-means algorithm is basically a centroid based clustering algorithm, which is going to, first of all, we have to mention how many clusters you want to create. Now, there could be multiple number of clusters. It could be like data can have 9 clusters. Sometimes data can have only 3 clusters. We don't know. So there are going to be different methods. It is going to be a iterative method where we are going to train the model on different number of clusters. That is going to be the value of K. Moving ahead, we are having a few more type of clustering over here. Then we have DBSCAN. Then we have hierarchical clustering. Hierarchical clustering is going to be a type of what we can say algometric clustering. K-means is going to be a type of centroid based clustering. We have K-means, we have X-means, but in industry, they're mostly using K-means. Then we have density based algorithm called DBSCAN. So DBSCAN is going to make the cluster based on the density, how the dense data is, how closely it is packed to each other. Hierarchical clustering is what I can say. It is outdated. No one is using hierarchical clustering nowadays. What you're going to see based on the data, based on the distribution of the data, people are going to use either k-means or DBSCAN to perform clustering. Yes, exactly, inherited group. So not we can say like inheritance, like you have studied in OOPS concept, but yeah, a sort of like that. Okay, moving ahead, let's talk about clustering. What we have before, we have the data over here. Okay, we have the data. So here, what k-means clustering is going to do, it is going to find where is the centroid. Okay, let's suppose k, the value of k data we have given. The in k means k represent the number of clusters. It is going to be the constant value that you have to select. Okay, you are going to decide. So let's suppose I want to create 3 clusters. So I will put the value of k as 3. Then 3 model will try to create 3 clusters. So it is going to simply put select any random data point, as a centroid, and it is going to calculate the distance between all the data points. Let's try to understand the k-means algorithm clearly over here. I'm just going to draw one more graph. All right, we have a graph over here, and I'm just going to put same color data points over here. Let's suppose I'm having data over here. I'm having some data points over here, and I'm having some data points over here. Now we are talking about the algorithm k-means. K means clustering. Okay, clustering. Now here k is going to be a constant value. Let's say 3. If I'm selecting 3, that means I am telling the model I want to create 3 clusters. I want to create 3 clusters. I don't know about the data, but I want to create 3 clusters. So what model is going to do? Model is going to select any random data point, not the center one. It is going to select any random data point as the cluster center. Then what it is going to do? It is going to calculate the distance between all the data points. So you can see like right now it is at the corner. If it is calculating the distance is going to be very high somewhere, it is going to be very low somewhere. So model is going to change the clusters center. It is just going to be an iterative process. Right now the cluster center is like this. Okay, the cluster center that we are having, it is like this. Just a second, I'm getting something over here. Yeah. Then cluster center can shift to this data point. Then it can shift to this data point. Until and unless model is going to achieve a cluster center, let's say this point. I'm just making it as red, where the distance between all the data point, or you can say within cluster sum of square over here is going to be a type of constant value. The variance is going to be easily understandable by the model. Then it is going to be selected for each and every data point. Now, what if a new data point is going to be, is going to come to a new cluster? Now, based on this, model has created 3 clusters. Let's say the clusters are like this data point, this data points, and this data points are 3 different clusters. How k-means clustering algorithm is going to identify a new data point? Let's suppose this new data point is coming over here. What k-means algorithm is going to do? K-means algorithm is simply going to calculate the distance of this data point to all the 3 centroids, this, and this. Now, which one is the nearest? let's suppose this, let's say class A, or sorry, cluster A, cluster B, cluster C. Let's suppose cluster A's centroid is the nearest. Then this particular new data point is going to be classified as the data point of cluster A. If I am having over here, then again it is going to calculate the distance from all the clusters. If it is going to find the nearest clusters, let's say B, then this new data point is going to be classified as the data point of cluster. This is how K-means algorithm is going to work. Now the question is, can we put only 3 always? Can't we have any other number? The answer is yes. You can have different number of clusters. Again, one question, how we are going to find out what is going to be the optimal value of K? That means how we are going to find out the exact number that we have to use for K. For that, we are going to use one method, is going to be, we call it as elbow method. Elbow method. Now there is no any module with the name elbow method. Elbow method will help you to understand which number of K is going to be suitable for the data that you are using. Is the nearest distance we want to take, sir? Yes, model is going to take the nearest distance, nearest centroid. We are not talking about any new data point. We are talking about the centroid right now. This data point, this one, these are nothing but centroids. Centroids. So first of all, let me write down the steps over here. So step number 1, what the model is going to do, model is going to select the number of centroids, okay, centroid or the K value. Then it is going to, like, randomly it is going to select the centroid, right? Then it is going to adjust the value to find the best data point, in the cluster. Just a second, let me shift some. Yeah, base data point in the cluster as centroid. Right now, basically what is happening here in the step 2, it is adjusting. Let's suppose first time, as I told you, this data point was the first centroid. Now it is going to keep it adjusting until and unless it is getting the data point where the variance between the data points are normal. Then what we are going to have next over here. So model is going to basically create the clusters. It is going to create the clusters. Then if you are going to find the new data point, if it's going to feed the new data point, it is going to predict the group or clusters, which cluster or group your data belong to. So these are going to be simple steps. So first of all, it is going to, like, we have to put this value of K. We have to decide what is going to be the optimal value of K. That can be done after all the things. Then it is going to find the best data point over here, right? Best data point where the clusters, the variance between the data points are similar. Then it is going to create clusters for them, like calculating the distance of all the data points. It is going to form a cluster and centroid will be decided. And if a new data point is going to come in the picture, it is going to simply predict which particular cluster this data point belong to, right? Okay, as is asking like what is its application? We have already discussed a lot of application in clustering. In clustering, basically, if you are going to talk about, mostly it is getting used in like what you can say in recommendation engine. YouTube is having a recommendation engine, right? What type of videos you are watching, similar type of videos you are getting recommended. In Instagram, what type of reels you are seeing a lot, the similar type of reels you see. On e-commerce platform, what type of products you're looking for, similar type of products you will get recommended over there. Then the ads, what type of product you're looking for, the similar type of ads you will see everywhere, right? Let's suppose I want to buy a smartwatch. What I'll do a Google search and all, right? Or I will simply go to any platform. If I search for a smartwatch on Amazon, I will be getting different recommendation of smartwatch from the Amazon. Not only that, if I just search on Amazon that I want to buy a smartwatch, I'm looking for it, then what will happen? You will get ads everywhere. On YouTube, on Instagram, everywhere you will be getting the ads of the similar products. Now, one thing I'll tell you, every one of you will relate. Before joining your college, all of you are in your college right now, right? Before joining the college, let's suppose you have just cleared your PUC or the 12th level, 12th exam, and you started exploring about the different college. The first thing you might have did, you Googled about the college, right? Top 10 engineering college in my town, top 10 engineering college in Delhi, top 10 engineering college in Lucknow, top 10 engineering college in Bangalore, Pune. What happened after that? You got seeing the ads of colleges everywhere. Whether you're using Facebook, Instagram, or YouTube, everywhere you might be getting the ads of colleges only. How it is happening? Because of machine learning over here. You are getting yes recommendation about the colleges and all. And mostly you are getting, let's suppose I'm looking for a particular course. Let's suppose I want to become an architect, right? I will be getting the ads of colleges, those who are like giving that particular course. Or I want to do an MBA, I will be getting the ads of all the colleges who are providing MBA, right? This thing happened to everyone. All right, got it. Okay, perfect, Asi. So I hope K-means is clear. This is how K-means work. Moving ahead, we have DBSCAN. Okay, Neol is saying I'm from non-coding background, so I don't know how to build the model, use code, but know how to train after attending these classes. Okay, you can do a lot of things. What was the name? Just a second. Yeah, Neol. You can do a lot of things. Like I'm not saying coding is hard and all. Coding is not that much hard. Even a sixth standard kid is writing codes. If you are going to talk to a kid nowadays, in schools are training the students on Python. School kids of sixth standard, seventh standard, I have seen, right? They're having coding subjects. They're writing the code. They're creating loops. They're writing the functions. This type of things 6 to 7 standard kids are doing. So it is not that much hard. Coding is just a tool that we are using to solve a problem, right? Use it as a tool. Don't think that it is that something that I have to know, like a big particular field. It is not that much big. It is just like give you a way to solve the problem. Okay, one thing here I want to add, like whatever the language you are learning nowadays, whether it is Python or you are learning Java or any other language, start thinking in that language, right? Simply, like if I'm talking in English, I'm thinking in English. If I will talk to you in Hindi, I will start thinking in Hindi. If you are going to write code in Python, start thinking in Python. That is the only way that you can be good at coding. Yes, exactly. It is just like a game. Yes, coding is nothing but a game. Right point you have raised over here, Prince. Coding is nothing but a game. You will enjoy, like you enjoy playing chess, like you enjoy playing Ludo and any other mind games. Coding is nothing but, you can say, a mind game. Start coding, you will have a lot of fun. All right, let's come to DBSCAN. Okay, the concept DBSCAN. So DBSCAN basically stands for density-based spatial clustering of applications with noise. And this particular algorithm is too old. It was proposed in 1990s. Now, before you, like that much how old it is. So in 1990s, this algorithm was proposed, and this algorithm was proposed to work on the data to form the cluster of data based on the density. Based on the density means what if the data points are closely packed to each other and there have some separation in the cluster, then we can use DBSCAN. So here there will be two parameters, that is going to be epsilon. So you can see there are circles. There are circles. These circles are going to be nothing but epsilon distance. Then we are going to have one parameter called mean. Mean means what? Minimum data point I want to take. All right. Let me talk about DBSCAN over here. How DBSCAN is working. Okay. Uh, if you are going to attend the interview and you are going to say that you have worked on any unsupervised learning or clustering project, interviewer will no, definitely they are going to ask you about this particular algorithm DBSCAN, how it is working. All right. Now let's suppose I'm having some data points. Let me increase the size, maybe. Yeah, I'm having some data points over here. All right. So in DBSCAN, this particular algorithm is going to have two things, that is epsilon, right? uh, I'm just writing it in this full form, epsilon, or you can simply call it as E, right? You can call it as E, epsilon E. Let's say epsilon E, I'm taking 6. Or one more thing will come, mean I'm taking 3. What does it mean? What does it mean? Mean 3, epsilon 6. So epsilon 6 is going to be nothing but, let's suppose from A to B, point A to B, I'm taking this particular distance, that is nothing but 6 units. Any units I'm taking about. Okay, don't think about centimeter and all, we are talking about units. From point A to B, from A to B, I'm taking 6 units of distance, that is 6 epsilon, E equal to 6. Then what will happen? Taking it as a radius, one circle will be formed. Now, if I am having, let's suppose data point A, A is a data point, B is nothing but a point over here. If data point A is having at least 3 data points in this circle, then it is going to be taken as, in the cluster. If the data point is outside of it, then this data point is going to be known as noise. I will ask you like which data point is noise, and this is going to be the center point, and these are going to be nothing but the points that are included over here in this epsilon distance, or you can say core point. Okay, this one is going to be the core point. Okay, talking about taking the epsilon distance, let's say I'm taking epsilon distance of, let me take one more over here. I'm taking epsilon distance of 6, and taking the epsilon distance, I'm creating one circle like this. Am I getting 6? I'm getting 3 data points. Yes, I'm getting 3 data points. Then again, new data point will be selected. And based on this data point, again, one epsilon distance will be created, and based on that, one circle will be created. And this process will goes on and on until and unless model is able to create the cluster of all the closely packed data points. Now this thing can be changed, the number can be changed. You can change the epsilon, you can change the minimum data point. I'm taking 3 for now. And the data point that is not a part of clusters, these data points are going to be considered as noise. This data point is going to be considered as noise. Okay, internet was gone wrong at that time. Okay, sorry, internet was gone. Okay, Uma Shankar, epsilon is nothing but the distance in which we are trying to create a circle within the epsilon distance. If 3 data points are there, then it is going to be the part of cluster. If let's suppose this data point, I'm talking about this data point, I'm taking 3 epsilon distance, but I'm not getting any what we can say, any cluster for that, right? So this data point are going to be considered as noise, right? If a bus stop for people when booking the seat, okay, okay, booking the seat, can minimum value is 1? No, minimum value 1 is going to mislead your model assist. If you are going to take the minimum value 1, at least you should go with 3. Okay, you can also go with 2, but not 1. If you are going to take 1, that means what will happen? Let's suppose I am having one, data over here, like this data points over here. What will happen? Okay, 1 I am having, okay, 1 cluster. 1 I am having over here, 1 cluster. So many cluster will get formed if you are going to take the minimum point 1. How to calculate a minimum value according to data? Again, it is going to be some iterative process. It is going to be iterative process. So if you are going to take the by default value, you can go with the by default value, or whatever the algorithm that you are going to use, you will find there is some by default value for that. Let me just show you on Google DBSCAN clustering scikit-learn. I'm just showing you the official documentation of DBSCAN. What you can see, epsilon is 0.5. Mean sample, that is the mean that I'm taking, is 5. I'm taking 3, but you can take 5. Okay. Similarly, you can also check for k-means as well. K-means scikit-learn, and it is going to be good for you guys if you are going through official document. Official document speaks a lot of things. By default, the n cluster, that is the number of clusters, the value of k is 8. Okay, but you can change. We can have 3, we can have 4, we can have 5. All right. I think DBSCAN is not efficient in today for used as algorithm. No, Prince. The thing is that it totally depends on the data. Okay, next slide. Okay, someone was saying noise as outlier. Yes, you can say that not reachable point. This n noise is nothing but a not reachable point. All right. Which is preferred clustering, sir? Very good question. Now the algorithm that is preferred for the clustering, it totally depends what type of distribution you are having in your data. Like you can see on the screen. If I'm going to have the data that is having good separation between 2 different clusters already, that is having 2 different. Now you can see on the first this, like this is looking like moons, right? So what you can see in DBSCAN, we are able to get nice separation, nice clusters. But K-means is a centroid based algorithm. So centroid based algorithm you are going to use when you are having the data like this, like this, or like this. Okay. The last three, I'm talking about the last three. This is where K-means algorithm is going to work in a good way. If data is closely packed, you can go with uh, centroid based clustering, that is K-means. If your data is not closely packed, but what you can see, some data points are closely packed, but we have a separation, and that separation is having a density, right? That particular separation is dense. When the separation in the data point is dense, we are going to choose DBSCAN. Blindly, you can go with DBSCAN. But if you are going to have the data points like this, you can see the last picture, the square I'm having. So DBSCAN is going to mislead over here. DBSCAN can be used when you are having a good separation in the data and you're having some density over there. Based on the density, like if you are having the data, separations like this, you can go with any of the algorithm. But for this closely packed, if the entire data set is closely packed, go with K-means. If the data set is not closely packed, you can see the good separation. First of all, you have to visualize the data, right? You have to visualize the data. Yes, K-means is separated by center data, or you can say centroid. DBSCAN is not separated by centroid. Yes, exactly, Prince. All right. Yes, we'll do hands-on. Okay, let's move ahead. So applications, so many of you are asking about the application. We have already discussed about the application. So yes, customer segmentation is going to be one of the popular use case. Customer segmentation means what? Identifying the customer based on their behavior. Behavior can be their purchasing pattern, right? How much amount they are spending. You can also say, like, few customers will come and they will buy anything. They will spend a lot of money. Few customers will come, they will be buying only products between some range, like 1,000 or 2,000. If customer is coming and buying the products in 10,000, then there could be a different category. And we can also divide the customer based on their age and gender to recommend something. So why we try to segment the customer into different category? There are different options over here. The first thing, we can recommend the products, similar type of products, to a single group at once, right? Like, say, I'm not going to identify the customer one by one. What I'll do, I will create a bucket where I'm going to have the customers of same behavior. I will be recommending similar type of products to them. And I can also, if I'm running a business, I have to give some offers and all. I will also identify the customers based on that I can attract based on the offer. I will tell them, okay, we are having sales of 50%, come to our store, right? Yes, Suman. Yes, exactly. Okay, so clustering analysis is having multiple examples, like retail and marketing, as I told you, like identifying the customers on the buying pattern, recommending something, some products, books, movies, reels to the customers or the viewer based on their behavior, what type of videos they are watching. Or you can also, like, see on Netflix also what type of videos you get. Let's suppose you are watching only horror movies, you will be getting horror movies in recommendation. If you're watching action movies, you will be getting more action movies in recommendations. Then in banking it is also having a lot of use, identifying the, you know they're trying to find which customers are loyal, which customers are more likely to like take loans, which customers we can target to sell them the credit card, right? The credit cards service. And based on the transaction also, banks try to understand the pattern Okay, what is customer churn? Nice question. Customer churn means what? Let's suppose I'm having a company, not company. Let's suppose I'm having a store. Okay, and there 100 customers are coming to my same customer, same set of customers coming to my store to buy the similar type of products every day. One more store got opened near me, but few of my customer started visiting to that particular store, the new store. That means I lose those customers. That customer stopped using my service, they discontinued using my service. That means we got a churn in the customers. The same thing companies also try to do with the employees churn. Which employee is going to, what type of employees we can see they are more likely to leave the company, who will stay longer. So company also try to understand which particular employee we can give good projects and all, or promotion and all, right? They try to find out the loyal employee, we also try to find out the loyal customers, right? And talking about the payments and all, whatever the payments you are doing, so basically, you are creating a pattern. You are doing the payment and you're creating a pattern. And whatever the payment you're doing, I'm talking about, let's say on UPI app, you are doing some payments. Mostly you are scanning the QR code, right? QR code of what? Shops, and you're doing the payment. But I will tell you one real-time story. What happened? I went to Tamil Nadu, okay? And it was late night around 11. I booked a auto and I paid that auto driver through UPI. I asked him to show me the QR code, and like there was not any, like Rapido, Ola service over there. So I booked some random auto over there and I reached to my place. I made the payment, and just after doing the payment at 11 o'clock in the night, I'm saying, I just got a call from my bank. Like it was the system generated call, like where I have to, like where I have to give the consent. Yeah, that payment was done by me. That was not any fraudulent payment. So this is what banks are doing nowadays. This is what banks are doing nowadays. They try to find out some anomaly, and you will also find the same thing in what you can say, uh, in Rapido and all. If you're only at nights, not only at nights, it could be in the morning also. If you're doing a pattern that is at different location, all of a sudden you're doing a payment at different location and some unusual amount that you are paying, that time you will get the call. So basically, okay, I hope you're using the same bank that I'm using, Prince. So basically I was not using that particular bank account. I, like once in a month I open that particular UPI app, I make the payment, the same payment I did, and I got the call from the bank. So in the fraction of second, they understand what type of payment is genuine and what type of payment is, it could be, fraudulent. It could be fraudulent credit card use, which bank you use. I am not going to, uh, I'm not going to promote my bank. My bank is okay, let it be. I'm not going to answer this question. Okay, I hope applications are clear. The more applications, yes, it is insurance, in publication, in medicine. In insurance, basically company try to evaluate the risk of the customer based on the segment. Based on segment means what? If a customer is, uh, let's say, if the customer is above 50, above 40, they could get more chances. Like I'm talking about health insurance, they could get more, chances to get admitted in the hospital or visit doctors. So they try to put all these things, in different bucket to understand basically what type of customers are going to be, more likely to claim the insurance, right? Or the insurance that is getting claimed by a customer is genuine or not. So many claims insurance companies receive that is not actually the genuine claim. It is also a false claim. So company have to also deal with that. Are you from IIT or NIT? Why do you think like that, Assis? Okay, Aditya is asking, I'm working on fake news detection project using Python, scikit-learn, and Streamlit locally in VS Code. Nice. Since I have already signed into Azure earlier and couldn't get free credits again, I use the local setup. Yes, it is totally acceptable. Miss Sahu, it is totally acceptable. We are not saying you have to deploy it somewhere, but you have done the project, upload it on GitHub, and when you're going to make your PPT, just put that particular GitHub repo link in that PPT. All right, perfect, perfect. Okay, talking about publication. Now there are different types of books in the market, but different books belongs to different genre, right? So here, to automatically categorize the books based on the content or news based on the content. So we are also using machine learning over here, unsupervised machine learning. And if you talk about healthcare, in healthcare also, it is getting used to again categorize the patient based on their similarities, right? That can be like helpful to understand what type of medical service they need, the different therapies they need, right? So these are the different applications. Sir, where I have to upload my project? So you have to upload your project in the LMS only. We'll let you know about that. Okay. Okay, so we will be moving ahead to our hands-on part. Okay, so in hands-on, let me take you to the hands-on directly. Just give me a second. So we are going to work on a movie recommendation system. We are going to use one clustering algorithm, and that will try to understand what type of movie you could watch based on the last movie that you have watched or like that. Okay, let's move ahead. Just a second. So I will be giving you that particular GitHub link that I have used. Just a second, guys. I'm just going to stop sharing right now. I'm stopping the screen share just for a minute. I will be sharing the screen again. I have to just grab the link. I will be sharing the link with you in the chat box. Just give me a second. So many questions I'm getting about projects. So that means you're not joining AMS sessions, right? You're not joining AMS sessions. Um, okay, let me share the screen again. I'll tell you how you are going to use this particular project. So this is the GitHub repo. What you have to do, I'm just sharing this link with you in the chat box. Here you go. The link is there in the GitHub repo, and this repository belongs to Selar sir. Selar sir uploaded this project. What you can do, you can download this particular project. So simply you have to click on code, you have to click on download zip. Okay, you can download the zip file, and when you're going to download the zip file, what you have to do, let me take you to the file location. Yeah, so you will receive this file, like you are going to get this file, a zip file. You have to right click on this file and you will be getting extract all option. So you have to extract, and you can extract and keep it anywhere. So finally you will be getting this particular folder where you are going to get these two things, that is going to be the notebook and the data set that we are going to use. Website is crashed. What? Try the link again. I'm sharing the link again. Why it is crashed? It is not crashed, guys. Could you repeat? Okay, sure, I'll repeat. So what you have to do, just a second, let me click over here. So I'm on the same page right now. You have to come and click here on code. Then you have to click on zip file, download zip. Okay, when you're going to click on download zip, what you're going to get? You're going to get this particular folder downloaded, not folder, a zip file. This is going to be a type of zip file. Okay, you can see the extension is .zip. So if you are having a zip file, you have to unzip it. So you will get this extract all option. If you're using MacBook, it's going to be a little bit different, but in MacBook also it is easy. Those who are using MacBook, they already know this process. If you're using any Linux operating system, the process are going to be similar, but you will be getting different options how to work with zip file. So when you are going to click on extract all, you will get the folder. Like I have extracted the things in the same folder, so that is in downloads folder, and you will be getting all these things. That is the notebook that we are going to use today, and this movie data set. Okay, so what is this data set about? So this CSV file will get by default, it will get open in Excel. Is asking me to convert or not. I don't want to convert it. So this is going to be the data set, guys, and you will find a lot of things over here, lot of fields, word count, the video, tagline, story, title of the movie, let's say Toy Story, Jumanji. I hope you have heard about this particular movies and all, right? And we are also going to have genre, like what type of genre it is, right? But we have to also work on the data. Now, if you see the genre column that we are having, it is holding a type of JSON file, right? A list that is holding a dictionary, a type of JSON file. So we have to extract the particular genre from that particular column. What this particular movie belongs to. So the movie is Toy Story. Story is basically from this genre, that is animation, a type of comedy, right? Comedy movie. Then you will find there are some action movie. Which is the action movie? What is this? Tom and Huck, right? So different type of movies are there. I hope you know more about movies than me. I don't need to tell you, right? So we are going to work on this data. Let's come back to the page, and here you go. This is going to be the notebook that I'm going to use today. So what we are trying to do right now, we are going to train a model. Basically the problem statement is going to be, if a person is going to watch a movie, a particular movie, based on that movie, how we are going to understand what type of movies could be suggested. So we have to build a movie recommendation system that is going to be a content based movie recommendation system that is going to suggest the viewer different movies based on the last movie that they have watched, right? Let's move ahead. So what exactly we are going to use? Yes, we will be using Python, and we will be using uh, for data exploring, manipulation of the data. We'll be using NumPy, and mostly we'll be using scikit-learn to uh, do the feature extraction and all. So here we will be using one of the vectorization method called TF-IDA vectorization. So I'll tell you when it is getting used. And we are also going to do some visualization using data visualization libraries. So these are the different features. So this is nothing but the metadata, that is the data about the data, what type of columns it is, right? And I'm not going to run this particular cell because all the things are already installed in my system. If you are using VS Code, so for the first time you have to install all the things. It is optional. Where we generated API key. Okay, we are not talking about API key right now, Meet. Okay, so here, what we are going to do, we are going to import all these libraries. These libraries are going to be pandas, numpy. There is one more library called ast. So for parsing the genre string, so genre, sorry, the genre string, the genre that we are having over here. So genres, the list of genres, right? we'll be using this library, and we are also going to use multi-level binarizer. It is going to help us to convert the string data to numerical data. We will be scaling the data with the help of min max scaler. And here comes our algorithm. So we are just going to use k-means algorithm for this. You can also try with DBSCAN. Okay, right now I'm showing you with k-means, but you can try with DBSCAN. Okay, the next thing, the matrix. For regression, we have used mean squared error, mean absolute error. For classification, we have used classification report, accuracy score, and all. What about clustering? In clustering, we use Silhouette score. Okay, Silhouette score is going to let us understand how well our model is able to create clusters, how well our model is going to understand the variance in the data. And we will be having these two libraries that is going to help us to plot the data. All right, let's go ahead. Here I'm just importing the important libraries. All right, and here I'm just going to read the data. So this is our data set. So our data set is having the records of 45,466 rows and 24 columns. We will try to use only the column that is required for us. We are not going to choose all the columns. We are not going to choose all the columns. Here I will also try to explain you with one example over here. If you have to, let's suppose you are having a car data. Okay, you are having a car data. You are having a car data. In this car data, let me create a squad over here. Just a second. In this car data, you are having, let's say, the mileage. Okay, the mileage. Then you are having, let's say, the horsepower, HP. You are having the cc, cubic capacity. Then let's say you are having the number of cylinder. You are having color of the car. Then you are having the model name. Like, let's say I'm having uh, Ford something, I'm having Mahindra something, like the names. Now, to let's suppose we have to divide the cars into three different groups. Just for an example, I want to divide the car into three different groups. Let's say one group is over here, one group is over here, and one group is over here. I will be giving you some names, and I want some names, like the things from you. Let's say this is bucket 1, bucket 2, bucket 3, or you can say the clusters. Let's suppose I'm having Tata Nano. I'm having Thar, having Scorpio, having, let's say, similar to that, similar to Nano, we are having, let's say, Chevrolet Beat, Honda Brio, let's say Swift. We are having, let's say, Honda City. Now, based on these particular features, how we can divide the cars into three different groups. Let's suppose I'm going to take Tata Nano over here. Can you tell me about few more cars that is like this? Let me put few things over here. Here I'm going to put Honda City. I'm going to put, let's say, Mahindra's Scorpio. Okay, can you tell me any car similar to Tata Nano? Any car similar to Tata Nano? Okay, Alto, very good. WagonR, very good. WagonR. What about this type of car, Honda City? Can you tell me? Nissan Micro. Okay, I will take Nissan Micro also. So many suggestions I got for this. Okay, Varna. Yes, nice example. Varna. Virtus. Okay. Civic. Okay, very good. What about these cars? Brezza also. Yeah, Brezza we can do. What about these cars? Like car type of a Scorpio? Can we take Thar? Yeah, I know this will come. Thar. So many people are taking Thar. XUV 700. Bolero. All right. Bolero. Okay. Now, on what basis you have, like, you are already deciding which bucket this class belong to, which cluster this particular cars belong to. How you are able to understand? Because this there are some categories for all these cars, right? We have decided the categories. Now, these categories could be decided from the mileage and horsepower. You can take these two columns. If you talk about mileage and horsepower, so these cars are going to give more mileage. Mileage will be high, but horsepower is going to be less. Talking about these cars, like here the mileage is going to be moderate and horsepower is going to be little bit higher than particular this above cars. If you talk about these cars, the mileage is going to be less, but the horsepower is going to be high. So basically, there are some categories of this car. So this type of cars we used to call it as. Let me change the pen size, guys. Just a second. Okay. So this type of cars we used to call it as hatchback. Hatchback. Sorry. This type of cars we call it as sedan. Sedan. Yes, very good. Hatchback, sedan, and SUV. Arvas knows about all this car, right? SUVs. These are SUVs, right? So they are having different similarity, but here in this data, I'm not having which category this class belong to. We have to decide the category. This is what through clustering we have to do. What my agenda was here to discuss this car data example, uh, to let you know, like based on what you are going to identify the data. Based on what we can say, this data belongs to this particular hatchback, sedan, or SUV. So we have to understand which features are going to be useful to us, right? We can't take color feature, right? Color, based on the color, I can't tell this particular car is a hatchback, sedan, or SUV. We have to understand what we have to understand, the domain. You have to understand the domain knowledge you have to get, right? Whatever the domain that you're working on, the project that you're working on that belongs to different domain, you have to understand that domain. If I'm working with car data, I should know about the cars, I should know about this automobile domain. If I'm working on bank data, I should know something bits and bytes of finance domain, right? Now, the domain problem that we are solving right now, this domain belongs to what? Entertainment, right? And every one of us are uh, we are all expert in this domain, entertainment, I guess. All right, so let's move ahead. So we are going to select the columns that is required. So what we are going to do, we are going to take title, genres, vote average, and popularity. So what we are doing, we are taking this particular data frame and these columns from this data frame. We are creating a copy of this. Why we are creating a copy? If I'm going to make any changes in this movie, it will not reflect to my original data. It will be like that only. Okay, as it is. So here we will be getting the movies. Let me show you this particular movies data frame. Here we have got, right, movies data frame. But the thing with movies is going to be, if you are going to look into this particular column, let's talk about the info of this column. This particular data frame, movies.info. So what you can see, there are some null values. Total number of entries is 45,466, right? 45,466. But here you can see it is not same. Something is missing over here, here also, like it is not same. So we will be dropping the null values as we are having a lot of data points, only few null values. If you're having 4 to 5 null values and if you're having thousands of rows, you can simply drop those values. So we are dropping the rows that is holding missing values or null values. So we are dropping the null values from genre, average, and popularity. Okay, so everything got dropped. Now, one thing is over here. As you can see in genre column, all the things we are having like this, right? We are having a list. In this list, we are having dictionaries. That dictionary is holding some keys and values, a sort of JSON file that you can see. So here we are going to create a function, a user-defined function that will help us to extract the genre names from the JSON-like string. Like it is a JSON-like string, as I told you, JavaScript notation, right? So what we are trying to do over here, we are having try and accept block. So in this try and accept block, what we are trying to do, we are trying to just use this particular function, AST library that we have used, literal eval, and we are just passing that particular string. So what will happen, it will create a separate list of that particular string, like it will extract the dictionaries. Then what we are going to do from that particular list, we are going to iterate over it and we are going to just take the name of that particular genre. We only need genre name, right? That is animation, adventure. We don't require ID and all. We just need this particular thing, that is name of the genre, not the IDs and all. If it is there, it's fine. If something is missing over here, then it is just going to give a empty list. So we are creating a list of genres and we will be creating all these things over here. So this function that we have created over here, we will be applying on genre column and we will be getting the genre list over here. Okay. So here, this is not any error. It is nothing but some warning. You can simply ignore the warnings. If you want to see this particular, you can simply view the movie's data frame again and you will be able to use. Now, what you have got a new column, right? We have created a new column called genre list. From this JavaScript notation like file, like JSON like file, what we have achieved? We have achieved the list of genres: animation, comedy, family, comedy, drama, like different type of genres we have got. And where it was having nothing, what we have got empty list, right? Now let's move ahead. Here we'll try to train the model and we'll also try to understand which value of k is going to be optimal. Okay, so here what we are going to do, we are going to take two things, that is going to be inertia values. So model is going to have inertia, right? When you are going to train the model, we will be appending the inertia of the model over here. Inertia of the model will help us to know the particular efficiency of the model. Then Silhouette score will help us to understand how well our model has understood the data, how well model is able to create the clusters. Then we are going to use this particular range as k values, right? Each time the number of k we are going to change. What was the by default value you have seen over here, right? By default it is 8, but we are not using 8 directly. What we are doing over here, we are running a for loop. In this for loop, the model will get trained from 2 to 21 clusters. Not 21, it is 20, right? The stop point is 21. That means 2 to 20. Each time the model will get trained with different number of clusters, we will be having the final features, right? We will be like this final features that we have created. We will be giving it to the model to train. And when the model is trained, we are going to take the inertia of the trained model and we are going to append it in this particular list that we have created. The same thing we are going to do with the Silhouette score also. Like we have created a list of Silhouette scores. So we will be taking up the Silhouette scores. Like we in Silhouette score, we have to pass the final features, the features that we have selected, and the labels. Labels is nothing but the model that they have, the model created the cluster. So each cluster is going to have label. Let's say label is going to be 0, 1, 2, like that. So it is just going to have the labels over here. It will try to understand and it is going to calculate all the things. So all these things will be done over here. Then what we'll try to do, we'll try to do some plot. So here we'll be having subplot. In subplot, like subplot is nothing but plotting multiple things together. So in the plot one, that is, you can see like figure and axis we have created. So on the same figure, we are going to have two things. What is Silhouette score? Silhouette score, basically it ranges between -1 to 1. And if you are having positive value, that means you are having good indicator. If your value is near to 1, that means your model is working fine. Like accuracy score, like we had in classification problem, here we are having Silhouette score. All right, so what we are doing, for each value of k, we are just uh, giving the inertia value, and we will be putting the marker O, like wherever the value is getting changed, we will be having a marker. Title we are giving elbow method. I told you, right? We are going to use elbow method to understand, right? To what is the optimal value of k. The same thing we are going to do with like here on the, sorry, on the x level, we have given number of cluster, that is k. On y level, we have given inertia, and we will be having a grid-like structure in the plots. The same thing we will be doing with the k values and Silhouette score. What was the Silhouette score on that particular value of k? It was high or low. Here we are using marker S. You can choose any other marker also. Marker S means what? Square. Color green. Marker O is nothing but circle. All right. So title we have given a number of clusters k on x-axis. On y-axis, we are having Silhouette score. Let's run the code. Let's have the things. Okay, something I have missed. Okay, I haven't run any line of code, I guess. Just a second. Some line of code I am missing over here. Just a second. I have run this. Just a second, guys. Let me see. Do I have any change over here? Otherwise, I will explain you through this particular file. No problem. Not initialized. Finally, yes, I can see, but the thing is that I was already having that thing, but why it is not here? Yeah, I'll do the same. Let me run all the codes from here. Just a second. Run. Okay, so let me do one thing. What I'll be doing. Yeah, okay, no problem. I think this code I have pasted above. I'll come back to it, guys. Uh, let's have few other things over here. Okay, I'll come back to it. I will be training the model after some time. Let's try to explore this data. Okay. So here we are having genre list. On the genre list, we'll try to understand what are the different genre we are having. So you can see the different genre that we have. The largest number of genre that we are having, it is for it is nothing for movies, right? We are having for movies. Which type of movies? Drama, then comedy, thriller, romance, and all. Okay, so what we are going to do now? We are going to prepare the model. Okay, the code was here. Sorry about that. So I have used that code above. No problem. So we will be using it again. Right now, this particular list that we are having, it is having what? It is having string data, right? We'll try to convert that string data into numbers. For that, we'll be using multi-level binarizer that will help us to turn the genre list into binary features that we need. Then what we are going to do, like we are going to use fit and transform that will fit and transform the data into numbers, and we are going to create a data frame of this particular columns. Okay, so if you're going to see the genre data frame, what you're going to use genre df. So for each column, a type of one-hot encoding, you can say. If Silhouette score is high, that means your model is performing well. If your Silhouette score is high. So here what we can see, like we are having action. Uh, Wherever you are having that particular in the row, if it is there, like for the Toy Story, it was animation, comedy, and family. We are having 1 1 for that. Rest of the genres are having 0. So this is what we are having, a type of 100 encoding. So what we are going to do, we are also going to rescale this particular features that we are having: popularity, voting average. We are going to perform min max scaler. So min max scaler is going to basically scale the data into range of 1, range of 0 to 1. All the values will get compressed between 0 to 1. That will help the model to learn better. Now what we have a scaled df now, and here I'm creating the final pictures. Okay, I have used the code above, so that was some mistake done by me. So pd.concat, we are concatenating genre df and scale df together, and we got the final features. Okay, let me do one thing. Let me copy the code from above where we have got the error. So this was not the place where I have to use this. We have to cut this from here. Let me delete this particular cell, and I will be pasting the cell over here. Here I have created. You can also fix the mistake over there, guys. I think the same file I have uploaded over there. Just a second. Okay, so here I'm going to run this particular code. Now it's gonna work. So it's gonna take some time, because you know the data set that you're using, it's quite high in the number, like 45,000 plus rows you're having, and you are going to train the model how many times? 2 to 20. That means 19 times your model is going to get trained again and again. So basically this for loop is going to take a lot of time. It totally depends on your system configuration, whatever system configuration you're using, and this plotting is not going to take that much time. Let it get trained. Yeah, final feature was not defined. I have seen. Okay. Glad to see that you are helping me to fix the problem. Thank you, everyone. Okay, so the thing was that when I prepared this file, so it was like some cells got misplaced. It should be here, but it got placed above. So what we are going to have over here, like we will be having a list of trend model, right? And that model we are going to store as inertia over here, the inertia values. Based on the inertia values, we are going to plot a graph. Okay. That graph is going to help us to understand which is going to be the optimal value of K. Let's let it be completed. I know it's taking a lot of time. Okay, what random state 42 does? Okay, the thing is that model is going to get trained on random data points, right? So this random state basically create random seed. Right, random seed means what? Let's say random state 42. That means 42 data points are going to be taken at a time randomly. All the things will go random. Okay, we are not giving top to bottom data set to the model. So how the data will get shuffled? With the help of randomness. Like what randomness you are defining. Random state is basically going to create random seed. That means I have created random state 42. That means 42 data points at a time will be taken and get shuffled. Okay. Okay, I'm just waiting for it to complete. It's not gonna take more time now. In this random state will affect the accuracy, and not that much. It is not going to affect the accuracy that much. If you're saying will it affect, will there be any, the answer is yes, it could be there in the accuracy and all, but not that much. It is like that what cell is misplayed, so session is end. No, it is running. I am waiting for it to complete. You can see the star mark over here, Prince. It is in progress. We are training the model 19 times. Okay. We are training the model 19 times. That's why it is taking so much time. Okay, let's wait for 2 more minutes. I know you want to see the graph and all, but already we are having a file over here. If it is consuming more time, then we'll go with that graph. But I want you to know see the output over here. That's why I'm waiting for it. Till then, any other doubt you're having, you can let me know. Let it be completed. We will see the graph. I got those two graphs elbow method. Okay, that means something is wrong with my system. Okay, let me save your time. Okay, let me save your time. Let me explain. You, I think you have got the things over here. What this code is all about. So when you are going to see the graph, like on the GitHub page, you can see. When I plotted these two graphs, so you will see a graph like this. Now, this graph is just looking like a elbow. Elbow means what? Our elbow, like hands. That's from here it got its name elbow method. And we are going to choose the number of cluster where we can observe model this particular thing, like this particular elbow is getting constant. Like here you can see it is 10. It is getting constant a little bit near 11 and all, right? So here what we can assume, like 10 could be the optimal value of k. 10 could be the optimal value of k. Not only here, not only here, we can also come up with this. Okay, here Silhouette score. Silhouette score, the highest we have got at 20, but we are getting constant over here like around 10, right? It is quite high. So what happens sometimes if when we are putting the value too much high, the score or the model could also get less understanding about the data. So here the optimal value that what we can understand, it could be 10 based on the given graph. It could be 10, but you can also, take 12 as well, not 20. 20 is going to be, lot of that. So what we are going to do, if we have decided if the optimal value of k is 10, then we are going to train the model again with the optimal value, giving the optimal value, let's say k, optimal value of k, and we are going to use this model. So what we are doing, we are just creating the model with the optimal value k, and we are asking the model to fit and predict the final features. Fit and predict the final features. So if I am having the optimal value k is equal to 10, then model is going to create 10 different clusters. Now here, what we are doing, we are giving the count of all the clusters. Count of all the clusters. So number 2 clusters, number 2 is quite high. Cluster number 2 is quite high. If you're going to see the graph above, let me just show you this graph above. So most of the number 2, if you see, like it was about animation, right? And all. I think we have also removed few of the things. It could be animation or drama. Moving ahead, like we got the model trained, right? We got the trained model. We have seen how many movies per cluster we are having, right? One question from Akash sir, above all of this, the analysis is data analysis. Okay. Yeah, so we are analyzing the data. Exactly. Okay, so data analytics is also having one type of analytics that we call as predictive analytics. That is nothing but machine learning. So right now we are on predictive analytics. And if I'm exploring the data, that means I'm putting the graphs, I'm doing descriptive analytics. Yes, this is data analysis. Data that we are analyzing the data that our model has generated. Very simple. Sir, I can see the visualizations after 9 minutes. Okay, it took 9 minutes for you. Okay, fine. Okay, let's come to the end part over here. I will close it. Now, what we are trying to do, we are trying to create a function, right? In which we are going to give the movie title and n equal to 5. Based on the movie title, model is going to recommend a 5 different movies to the user. That is already over there. So here what we are having, so we are having movie title. We are taking that particular title from over here. We are creating a target value. Okay, target value. We are creating some if and else. If the target value is empty, then we will be having movie title not found. Okay. Then what we will be doing here with the help of that particular cluster data that we have created. So here you can see like we have created one column called cluster, right? We have created one column called cluster. So we are going to work over there. If the cluster, like if the cluster that we have given over there, if the cluster is found over here, the value is 0. That means the first index. So we'll be taking it as cluster ID. All right. And over here, what we are doing, we are trying to find two things over here. We are including two things. Movie cluster is equal to cluster ID, and movie title is not equal to the title. That means what does it mean? It is so it should not repeat the same title. If I have passed Toy Story, I should get the movie related to Toy Story. I should not get the same movie again. So similar movie is going to be selected with the help of IDs. ID means what? The same genre. And it is going to return few things. That is going to be title, vote average, and popularity. We are going to sort it out, sort the values based on what? Voting average and popularity. As we have to sort it from high to low, that means the highest vote I have to show on the top. I will be doing the ascending as false. Ascending as false means what? By default, ascending is true. But if I'm going to make ascending as false, I will be getting the things in descending order. That is high to low. And head, as it is going to return the data frame, I have given head n. N means what? Show me only 5. And here we go. So when I have just given over here one name, based on name, I'm getting what? The movies recommended. These are the movies that I got recommended. And it is coming from the same data set. You can see different indexes there. So for the Toy Story, related to Toy Story, what I have got? Lion, The Lion of Thieves, Patience Zero, High Roller, Tokyo, 10 Winning, like this type of movies. So okay, my visualization is also done, but the same type of result you are also going to get over here. That's why I have used the same over here. Okay. I hope it is clear to all. Okay, I'm getting the message. Chris is saying understood, sir. Is it clear to all? Any confusion you are having? Are you able to understand the concept of clustering? How clustering is going to help us to solve the problem? How to make project on mobile? AK mobile you can do on mobile. So what you have to do, you have to use online platform, but on phone it is going to be tough. If you're not having laptop, I hope you're going to college and your one of your friend is bringing the laptop. Try to sit in recess time and try to complete the project through the laptop. In mobile, you can use online platforms like Collab and all, but it is going to be very hard for you to do the project on Collab. Okay, I would recommend you to go through like use a laptop. If you're not having laptop, plan to buy a laptop. All right, that's all for the day, guys. I hope you have got. Okay, no. All right, so I think everything is clear, right? Perfect. So similar movie is just going to what we are doing over here is try to understand. So it is just taking the cluster ID, that is cluster equal to cluster ID. That means similar ID. And we are also taking this thing like where the same movie is not repeated in here in the similar movies. That is what we are doing. So cluster ID, what we have, if you see the clusters over here, let me come over here. These are the cluster IDs 0, 1, 2, 3. Wherever the clusters are same, we are just taking that particular same recommendation from the model. Okay, guys, ma'am has already sent the attendance link in the chat box. So you can fill out attendance form. All right. Thank you. Thank you for your good words, Arbaz. Yes, you will get the project template in the group. All right. Yes, over to you, ma'am. Kartika ma'am, are you there?
Yes, yes, teacher.
Yeah.
I'm sorry. Yes, students, I have given you the attendance link. Please use a proper link to fill your attendance. Okay. Some of you are saying that the attendance link is not working. It should work. Okay. You need to ensure that you are using your registered ID on your LMS. If you're using some other IDs, the link may not work. Okay. So the link is working fine for now. Even if you have missed the previous sessions, you can find the link in the Telegram group pinned messages. Please go through the recording once and then fill your attendance. Okay, so we have the attendance links for all the sessions. In case if you missed any sessions, please go through the recording and then you are good to mark the attendance. Okay. So please keep this thing in mind, and project template, the trainers will send you in the group. And second thing, still many students are asking, ma'am, what could be the title of the project? We have clearly mentioned that it is your choice. You can pick any project of your choice, but you need to infuse artificial intelligence and machine learning in that. Even there are lots and lots of inquiries came in the YouTube comments today. But please, do not miss any sessions. If you miss, then again you have to you will be keep on asking the same things again and again, which we've been discussing in the sessions already. Okay, so I would suggest you all to go through the recordings once again of the missed sessions and then start working on your project. Okay, the link is there in the chat section and as well as in the YouTube. I will also be sharing the same in your Telegram group. Okay, thank you so much. Thanks, everybody. Thank you, sir.
Thank you. Thank you, everyone. Thank you, ma'am.